Hey, welcome to The Explainer. Today, we are going to crack a code. Not just any code, but the code that organizes our entire world. The invisible system that tells us exactly where we are and even when we are.
All right, let's start with this picture. Just a simple scene, right? A house, a lake, a road. But the moment you really look at it, questions just start to pop up. Like, where does all that water come from? Who built that road and why is it even there? What's the story of the people who call this place home?
And you know what's wild? Those small, specific questions, they spiral out, and suddenly we're face to face with the biggest questions of our time. We're talking about everything from social tensions and conflicts to the massive stress we're putting on our planet. And finding the answers? Well, it's definitely not simple. So how do we even begin to tackle all that? Well, you need the right tools. A special kind of toolkit. One that's designed not for studying atoms or stars, but for understanding the incredibly complex web of human life itself. What we need is a science of society. And that toolkit? It's called social science. Its whole purpose is, well, it's pretty big. It's about studying human societies, not just to understand where we've been, but to make sense of right now, and to help us build a better, more peaceful, and more sustainable future.
Now, what's really cool is that social science isn't just one thing. Think of it more like a powerful set of 5 different lenses, all interconnected. You've got geography, our place in the world, history, our journey through time, culture, our shared identities, governance, how we organize ourselves, and economics, how we manage to get by.
Because really, think about it. Before you can understand history or culture or anything else, you've got to know the answer to the most fundamental question of all. Where are we? And that makes geography the bedrock, the foundation for everything else we're going to explore. Okay, so let's start our journey with a tool you've probably seen a million times, but maybe never really looked at. The map. It's something we take for granted, but we're about to see it in a whole new light. So at its most basic, a map is just like a treasure guide, right? It shows you where stuff is and how to get there. But like any good guide, it has its own secret language, and it's made up of 3 key parts. And it turns out, every single map out there, from a crumpled up city plan to a giant world atlas, it's all built on the same 3 basic ingredients. First, you've got distance, which we see as the map scale. Then there's direction, north, south, east, west. And finally, you have symbols, which are like the little pictures that stand in for real-world things. And this is where we hit the big problem with map making. You see, you just can't flatten a sphere perfectly without messing it up. The best way to think about it is like peeling an orange. If you try to lay that peel perfectly flat, it's going to rip, it's going to stretch, it's just not going to work. And that's exactly why a globe is always going to be a more accurate picture of the Earth, even if a flat map is way easier to carry around. So that leads to a big question. If our planet is basically this giant, smooth sphere, how in the world do we pinpoint one exact spot on it? Well, humanity came up with something brilliant, a kind of secret code, a universal system that works anywhere and everywhere. And the key to this whole code is actually an idea you use all the time without even thinking about it. Imagine you're meeting a friend in a huge, crowded market. You wouldn't just say, hey, meet me at the shop, right? No, you'd say something like, meet me at the 7th shop in the 5th row from the entrance. And boom, right there. That's a coordinate system. It's so simple but so powerful. By using just 2 intersecting points of reference, you can find any single spot with perfect precision. So we've done the exact same thing for the entire planet. We've wrapped the Earth in this massive, invisible grid of lines. And these lines have names. You've probably heard of them, latitude and longitude. All right, first up, let's talk about latitude. The easiest way to picture these are like horizontal hula hoops stacked on top of each other, running east to west. They're parallel to the equator, which is our big starting line at 0 degrees. Basically, they tell you how far north or south of the equator you are, all the way to 90 degrees right at the poles. Okay, then you've got longitude. These lines run the other way, vertically. Think of them like the slices of an orange, going from the North Pole all the way down to the South Pole. They tell us how far east or west we are from their starting line, which is called the prime meridian, also at 0 degrees. So here's the beautiful part where it all comes together. Latitude, those east-west lines, they tell you how far you are from the equator, and that's super important for figuring out things like climate zones. But longitude, the north-south lines, they do something totally different, something you might not expect. They define our time. And hey, here's a really cool piece of history for you. This whole idea of a prime meridian, a 0-degree starting line, it's not some new modern thing. Centuries before the line was officially set at Greenwich in London, ancient Indian astronomers, like the brilliant Varahamihar, had their own prime meridian running right through a city called Ujjain, which was a huge hub for astronomy back in the day. Okay, so let's dig into that. This mind-bending connection between where you are on the globe, your longitude, and what time it says on your watch. It's pretty much a race against the sun itself. You know, way back around 500 CE, the great astronomer Aryabhatta pointed out that the Earth is a sphere and it's spinning in space. And it's that constant rotation that makes the sun look like it's moving across our sky. That's what creates day and night, and it's why every single sliver of longitude has its own local time. And the math behind it all boils down to one single magic number: 15 degrees. See, the Earth spins a full 360 degrees in 24 hours. You do the math, and that works out to 15 degrees of longitude for every single hour that passes. That number is the key that connects our location to our clocks. Okay, let me break down how that actually works. Let's say it's exactly 12 noon at the prime meridian. If you travel 15 degrees to the east, the sun has already passed its highest point an hour ago for you, so your local time is 1 p.m. Now, go 15 degrees west instead, and it's only 11 a.m. See? Every 15-degree jump is a 1-hour change on the clock. So what happens on the exact opposite side of the world at 180 degrees longitude? Well, that's where things get really weird. That's the international date line. When you cross that line, you don't just change the hour, you change the entire day. Go west and suddenly Monday becomes Tuesday. Go east and poof, Tuesday flips right back into Monday. So when you get right down to it, latitude and longitude are so much more than just lines on a map, right? They're the universal code for pinpointing ourselves in space and even in time. And once you understand this global grid, it's really the first step to seeing how our entire world is connected. So the only question left is, now that you have the code, where in the world will you explore first?